Imagine a force so vast it holds the coldest air on Earth captive, swirling silently above us, a spinning giant guarding the polar regions. Most days it keeps the bitter cold locked away at the top of the world, unnoticed by those below. But sometimes, this guardian falters, it wobbles, it breaks. When it does, a river of Arctic air spills across continents, an invisible invasion that can freeze cities and disrupt modern life. This is the polar vortex, a real, powerful feature of our climate system. When it loses its grip, temperatures can plummet by dozens of degrees in hours. Cities fall silent, encased in ice and snow, the air sharp and biting. Headlines scream, Arctic blast, deep freeze, record-breaking cold, signs of a disrupted polar vortex. This isn't just a local event, it's a weather system that operates on the scale of an entire hemisphere. When a piece of the vortex breaks away, it brings the essence of the Arctic night, air that hasn't seen the sun for months, straight to our doorstep. It's a stark reminder that Earth's systems are deeply interconnected. The story of the polar vortex is one of balance, a delicate dance between temperature, pressure, and planetary rotation. It plays out high in the stratosphere, far above where jets fly. For most of history, we were unaware of this titanic struggle overhead. Now, with modern science, we can see and understand it. And in understanding, we appreciate the powerful forces shaping our world. A wobble in the sky can change everything on the ground. So, what exactly is the polar vortex? It's not a visible storm, but a massive area of low pressure and cold air swirling high above the poles. Picture a spinning top of wind, counterclockwise in the Arctic, clockwise in the Antarctic, driven by the temperature difference between the poles and mid-latitudes. The vortex exists in two layers: the troposphere, where weather happens, and the stronger, more stable stratosphere above. In winter, the stratospheric vortex becomes a tight, cold whirlpool, with winds over 100 miles per hour fencing in the coldest air. When strong, it keeps Arctic air contained, maintaining stable climates for the mid-latitudes. The jet stream below flows more directly, making winter predictable. Cold, but not polar-level cold. The polar vortex isn't new, it's been part of Earth's atmosphere for eons. What's new is our awareness and understanding of its impact on our lives. For centuries, people endured sudden cold snaps without knowing the cause. Now, satellites and weather balloons reveal the massive, spinning vortex above. We can finally see the cosmic dance shaping our winters. A strong polar vortex is like a well-behaved spinning top, but when it weakens, it wobbles, distorts, or even splits. The fortress walls crumble and Arctic air escapes south. The vortex becomes wavy, sending lobes of cold air deep into North America, Europe, or Asia. The Arctic may warm as its cold air leaves, while other regions plunge into a deep freeze. The jet stream, influenced by the vortex, also becomes wavier, creating deep troughs and high ridges. A trough brings frigid air and snow. A ridge brings warmth elsewhere. A weakened vortex means extreme stuck weather patterns. Intense cold in one place, surprising warmth in another. This isn't the end of the world, but a dramatic part of climate variability. Such disruptions have always happened, but their intensity and frequency are now under close scientific scrutiny. A weak vortex can lock regions in relentless cold for weeks, challenging infrastructure and daily life. It's a powerful reminder, our comfort depends on a thin layer of warmth atop a very cold planet. When the sky wobbles, we all feel it. For many in North America, polar vortex became a household term in the winter of 2014. That January, the vortex weakened and broke, sending a lobe of Arctic air deep into the U.S. Temperatures in Chicago plunged to minus 16 degrees Fahrenheit, minus 27 degrees Celsius, with wind chills far colder. In Minnesota, it hit minus 36 degrees Fahrenheit, minus 38 degrees Celsius. The cold was so intense people heard the air crackle. Boiling water thrown into the air instantly turned to ice crystals, a science experiment on a continental scale. The impact was immediate. Schools and businesses closed, flights canceled, pipes burst, and energy grids strained. Over 200 million people were affected. More than 20 lives were lost. The 2014 event was a textbook case of a weakened polar vortex. While the U.S. froze, Alaska and Europe saw mild weather. The cold air had been displaced from its Arctic home. This event did more than freeze pipes, it sparked a global conversation. Suddenly, a complex atmospheric concept was on everyone's lips. We all looked up, wondering about the immense invisible forces at play. The polar vortex had made itself known, and we realized just how vulnerable we are to the whims of the sky. What knocks the polar vortex off balance? One main culprit: sudden stratospheric warming, or SSW. This isn't warming you feel on the ground. It happens high in the stratosphere, where temperatures can spike by 90 degrees Fahrenheit, 50 degrees Celsius, in days. Powerful atmospheric waves generated by air flowing over mountains or land-ocean contrasts travel upward and break in the stratosphere, releasing energy. This energy disrupts the vortex, slowing its winds and warming the air like grabbing a spinning skater's arm. The wind barrier breaks down, letting cold air collapse downward and outward. SSW events give forecasters a crucial heads up. A major cold outbreak could be coming in the weeks ahead. How is climate change affecting the polar vortex? The Arctic is warming faster than anywhere else, a phenomenon called Arctic amplification. This reduces the temperature difference that powers the vortex, potentially weakening it and making the jet stream wavier. A wavier jet stream sends more energy into the stratosphere, increasing the chance of vortex disruptions and sudden stratospheric warmings. Paradoxically, a warmer Arctic could mean more severe cold snaps for some regions. This doesn't contradict global warming, it's about a more chaotic, less predictable climate system. The warm Arctic cold continents pattern is a prime example of this complexity. Scientists are still debating the strength of this link, but evidence is mounting that rapid Arctic changes ripple across the hemisphere. Understanding this connection is crucial for predicting future winters in a changing world. How do we study a spinning column of wind miles above us, with a blend of technology and ingenuity? Satellites monitor the atmosphere from orbit, measuring temperature, wind, and chemical composition. Weather balloons, launched daily worldwide, provide direct measurements as they rise through the atmosphere. Ground-based radar and LiDAR systems measure high-altitude winds. All this data feeds into powerful supercomputers, running complex models of the atmosphere. These models help scientists test ideas, understand vortex breakdowns, and predict future behavior. Better predictions mean more time to prepare for cold snaps and protect communities. The polar vortex isn't just science, it impacts our lives, economy, and safety. When Arctic air plunges south, it tests our infrastructure to the limit. Power, transportation, and housing systems built for normal weather can fail under the strain. A single cold wave can cause billions in damaged burst pipes, closed businesses, canceled flights, and lost crops. Extreme cold is a public health threat, especially for the vulnerable. Energy grids are strained as demand skyrockets, sometimes leading to blackouts. Preparation is key. Warming shelters, robust infrastructure, and clear communication save lives. Understanding and predicting the vortex isn't just curiosity, it's about protecting communities. Improved forecasts give governments and citizens precious lead time. This allows for resource planning, public warnings, and protection of the most vulnerable. In our dance with this force, knowledge and preparation are our best defense. The polar vortex reminds us nature's power is real and we must be ready. Our resilience depends on it. The polar vortex is a humbling force, a silent spinning giant shaping our world. Most of the year it's distant and abstract, but when it reaches out, it commands our attention. It reminds us that Earth's systems are deeply interconnected. A warming Arctic can trigger a chain reaction, freezing cities far away. Our actions are altering these systems, making connections more volatile. The polar vortex is a messenger from the changing top of the world. Our quest to understand it is a testament to human curiosity and ingenuity. By learning, we can anticipate, prepare, and build resilience. Next time you feel a blast of cold air, remember the immense invisible river of wind above. The polar vortex is more than weather, it's a cosmic force and a call to be better stewards of our planet.